In this lesson, we're going to look at insert mesh brushes. Insert mesh brushes are found under the brush menu, I for insert, and you'll find that there's a variety of brushes here that begin with the word IMM. That stands for Insert Multiple Mesh. So if I were to select one of these, say for example the IMM Parts brush, you'll see that I get a selector of different meshes up here at the top of the screen. Now, what the IMM brushes do, or the insert mesh brushes, are they insert one of these meshes into an existing subtool. Now, it will not make a new subtool. It inserts it into the existing one. So if you see here, our current mesh is this polygon cube. It only has a single subdivision level. If you look at the geometry menu here, there's no subdivision levels on this mesh, and that's important because InsertMulti Mesh brushes will not work if you have subdivision levels. We'll talk more about that later. So with the IMM parts selected, I'll just grab this bolt, turn on X symmetry, click and drag, and I can draw this mesh. We'll turn off frame mode, and you can see what it's done. It's inserted this mesh into this subtool. It has not created a new subtool. This is just inserted into this mesh. You'll also see that it has masked the tool that I've drawn it into. That allows me to take the transform button here. We'll unlock the gizmo, reset it, lock it again, and now I can move these around without affecting the surface that I'm drawing them onto. I can change the depth. I can even scale and manipulate these pieces. If we go into frame mode, you see that the insert mesh brush retains any polygrouping that it had when it was created. This allows us to further manipulate our insert meshes if we retain polygrouping on our models. Again, we'll talk more about that in a moment. Now, once it's drawn on there, Control, click, and drag on the background clears the mask, and now I can draw another. We'll select this bolt here. We'll draw this onto the surface. Now, if I go into transpose mode and then select other meshes, I can swap out what's being inserted. Press Q to leave transpose mode, and there we go. Now, when I draw my insert mesh, let's grab another one here. We'll grab this one, this bolt. We'll draw that on the surface. Now, I'm going to go to my brush menu and open up the depth control here. That's a sub-menu under the brush menu. And that black line represents the surface, and the dot represents the center of the brush. So if I bring this down to the mesh surface, click and drag, you see that it inserts that mesh deeper into the surface. So we do have control over the depth of the stroke. Control, click, and drag on the background clears the mask. Now, another neat thing that we can do is if we want to draw our fasteners all the same size. Let's say I've grabbed this bolt here and I draw it on the canvas, and I want to draw another set of bolts. It's hard to eyeball them the exact same size. So what we can do is take our draw size, adjust it, start drawing that insert mesh on the canvas, and then if you press and hold the Control key, it will lock it to your draw size. So now if I draw another one and press and hold Control, make sure that you start pressing the Control key after you start your stroke. It will draw those the same size. Now, another neat thing that we can do here is after we draw our insert mesh brush onto the object, go into transpose. I'm going to unlock the gizmo and reset it, lock it again. Now, if I hold down the Control key and click and drag, because there's no subdivision levels, it will duplicate this mesh. So I'll drag it whatever distance I want. Then if I let go of the Control key, I can continue duplicating that the same distance down my axis. Clear the mask, and there we go. So the insert mesh brushes are really useful for adding greebles or little mechanical details, or taking an object and adding further complexity by adding extra parts to it. Now, if we go back to B for brush, I for insert, the InsertMulti Mesh brushes, there's a few different types. Most of them are mechanical parts, like machine parts here. You see these are various machine parts. My favorite is B for brush, I for insert, IMM model kit. This contains a plethora of different pieces and parts that are really useful for making hard surface models. Now these, as I said, are really suited for hard surface. There's also other types of insert mesh brushes. There are costume-based ones, which tend to be based around curves. There's the IMM curve brushes here, which create things like stitches. We go to our side view, Control, click, and drag to clear the mask, and then draw along the edge here, we get a curve. And this inserts these stitches or these laces along that curve. Now we'll talk more about curves in a moment. If I go back to the insert mesh brushes again, we have IMM Boolean. That's specifically for Booleans, and we'll talk about that in the chapter on Booleans. We also have IMM B parts. Now IMM B parts inserts body parts. These are intended for use with Dynamesh. So right now, these hard surface and costume details, we typically don't want to Dynamesh these together. However, if we are working with a Dynamesh, we can kit bash or take parts and glue them together to make a new character. And we'll talk more about that in just a moment. Before we move on, I want to talk about using IMM brushes with a smooth surface. So I'm going to turn my undo history back to the beginning, where we've got our cube with no subdivision levels. So let's step up to no subdivs. So let's say I want to add my insert mesh brushes on something that has the appearance of being smooth. So there's no way to do that. If I add subdivision levels to this mesh, actually I'm going to undo back to the very beginning of the cube here. There we go. So if we go into frame mode, there you see we have a very, very light geometry. If I Control D and add a subdivision level, you see it smooths the mesh down. So add a couple subdivs, and that sort of softens the edges of that cube. Keep that in mind. If you add subdivision levels to a low poly sort of cubic or hard surface tool, it's going to smooth it down. So bear that in mind. Now if I try and use my InsertMulti Mesh model kit brush, grab a piece, then try and add it, it says this mesh is composed of multiple subdivision levels. So I can't use my insert mesh brushes if I have multiple subdivision levels. How do we get around that? So let's undo our subdivs so we're back to our original cube. What we're going to do is we're going to go to the geometry menu and then open up dynamic subdivision levels. Dynamic subdivision levels allow you to give your mesh the appearance of being smooth while not actually smoothing it. It's great for using with InsertMulti meshes. We also use it in cloth when we want to add thickness and we want to have a lighter low-res mesh that we can run cloth dynamics on. So there's a few uses for this, and we talk about it in a few different chapters in this series. Here we're going to use it to create the illusion of a smooth mesh. Then we'll use our InsertMulti Mesh brushes. Then we'll turn it into actual subdivision levels. So again, if I were to smooth this mesh with the SMT modifier turned on right now, this is what it does. It shrinks the edges of it. So keep that in mind. I'm going to go to dynamic subdivision levels and turn them on. And you see that gives me the same sort of effect. It smooths over the edges of that cube. Now, what if I want more geometry on a hard surface tool, but I don't want to smooth over the edges? Say, for example, I want to add some dents and scratches to it. What I would do is, this is not dynamic subdivision levels, this is showing you what actual subdivision levels do. If I turn off the SMT modifier and then add a division, that adds a subdivision level without smoothing. You see? Then if I turn it on and then start dividing, I retain the volume of that cube. But that's adding geometry. So let's undo that, and I'll show you how to get that same effect in dynamic subdivisions. And that's important to keep in mind. If you import or create in ZBrush a hard surface model that doesn't have really dense geometry, turning off SMT allows you to divide it, then turn it back on, and then you can get a nice sort of smooth edge there. And that will allow you to do things like if you want to create, let's say, denting on a bit of armor, I can go to my spray stroke and an alpha like this and turn down my Z intensity, hold down the Alt key, and then I can create denting on the surface and get some more. That brush size is too big. I can add some distressing to a hard surface model. So that's why we would want to do that. So if we want to get that with dynamic subdivision levels, what we do is go to dynamic, turn it on. Now the default behavior is flat subdivision level 0. If I turn this up, you see that that now gives me a bit more of my volume. I can also come over here, take flat subdivision levels, turn it up to 2, and get even more of my volume. Now what this is doing, it's the same as smoothing with SMT turned off. If I bring flat subdivs down, I could take QGrid, turn this up to 1. Now you see I've got the option for a bevel. I can adjust beveling on here. I can change Q grid to 2, and it sharpens it up. So this allows you to control the type of smoothing that you're getting. Now, here I've got 2 smooth subdivision levels. Now, these are the dynamic subdivs. These don't actually exist as geometry. This is dynamic subdivision. So now if I go back to my InsertMulti Mesh brush, we'll grab machine parts, grab a piece, draw it on there. It draws on that mesh. Let's grab something that's like a fastener here. Let's go to B for brush, I for insert, and we'll go to industrial parts and grab a flathead screw. Draw that on there. Now notice that the smoothing also affects my insert mesh brushes. So if I change my Q grid back down to 0, you see that that retains the hard edges there. Bring my flat subdivisions up to 1. That gives us a more accurate look to that surface. So be aware that the dynamic subdivision levels are also going to impact your insert meshes as you draw them onto the surface. So you will be impacting the hard edges of those pieces as well. So these nuts here, if I were to change my flat subdivs and change my Q grid, you see that that actually smooths those down to cylinders. So be aware that this is going to impact the effect of your smoothing on your insert meshes. Now, once I've done my insert meshes and I want to turn this into actual geometry, simply click the apply button here, and now that applies those 3 subdivision levels. So this is actual subdivisions now. I'll clear the mask, and those are actual subdivs. So dynamic subdivision levels are really useful when you're working on hard surface models. They are also usable in Booleans. If you watch the chapter on Booleans, or the chapter on folders, we do have an option in our folder menu. If I turn on new folder here, if I go to the gear icon, you see that we have the option to Boolean a folder. We talk about this in the Boolean chapter. There's also Boolean with dynamic subdivision levels. So you can use dynamic subdivision levels with Booleans, and they'll automatically bake down into actual geometry when you Boolean them if you use that option. Now, how can we create our own insert mesh brush? So these are InsertMulti Mesh brushes. These are multiple insert meshes contained into a single brush. So I'm going to go to this object here, which is available for you in the downloads for this class. And this is just a single subtool with no subdivision levels on there. If we go into frame mode, it's relatively lightweight. So if I want to turn this into an insert mesh brush, I'm just going to select just a different brush now to get rid of the mesh selector up top. I need to store this as an insert mesh brush. Now, when I store it, the orientation on screen is important because that represents the position of the model when it grows out of the surface. So to make an insert mesh brush, position your model. If I've got polygrouping, it will retain its polygrouping. I go to Brush, Create Insert Mesh. Now it's going to ask me if I want to append it to the current brush or make new. I'll click New. And now this has created a new insert mesh brush, and the little number tells me that there is 1 mesh in there. If I click and drag, you see that it draws that mesh on the surface in the same orientation at which it was stored. So if I change my orientation, let's turn it around to the back view, and then once again, I will go to Brush, Create Insert Mesh. This time I will append it to my current brush. Now I have a second mesh, click OK, in this InsertMulti Mesh brush. If I draw it now, it draws in this orientation. If I press the M hotkey, this brings up the selector for the different meshes that are stored in this brush. If I change the orientation to the top view and then go to Brush, Create Insert Mesh, Append, click OK, I now have 3 mesh orientations stored. So there's 1. We'll select this one. There's 2. We'll select this one. There is 3. So now I've got 3 different types of meshes that I can insert using this single brush. And then you can save this by going to the brush menu, Save As, and you can save this brush as anything that you like and load it up at any time you want to use it. Perhaps I like this particular piece here. I think it makes a nice bit of mechanical detailing. Well, what I can do is I can orient on screen, and I can say Brush, Create Insert Mesh, Append. You can click OK or skip that note, and now I've got this as an insert mesh brush. So I can click and drag and then draw this on the surface anytime I want. So click drag, and now I can add this onto the surface, adding further complexity and detail. Clear my mask, and there we go. You can see how very quickly you could create some type of maybe futuristic cityscape or props or different elements. It's a very, very powerful tool. Now, what if we have a more complicated object that we want to turn into an insert mesh brush? For example, this lung socket here. This has multiple parts to it. If I go into frame mode, you can see. Now, I've used this in a couple other demonstrations. This is from the COVID Demoni project. Now, what I've done to this is I have decimated the subtools, so they're triangulated. That reduces their overall polygon count. And then I've merged them together using subtool, merge down into a single subtool. And the reason we do that is because an insert mesh brush, if it's a million polygons, your subtool, if you store that as an insert mesh brush, every time you draw it on the surface, you're adding another million polygons. So decimating this gives you the ability to have a lighter mesh that retains the look of detail, but it's not going to eat up memory. Now, to learn more about Decimation Master, there's an entire chapter on Decimation Master, and there is an entire chapter on working with subtools, so you can revisit that. And I'll also append the process that I use to actually reduce this into the end of this section, because I don't want to overcomplicate this lesson right now by diving into other tools and other techniques. So I've got this piece. It has much more complexity. It retains its polygrouping. I will orient it on screen, and I will go to Brush, Create Insert Mesh, Append. And now that appends that lung socket into this tool. So if I press the M key, I can select my meshes. I'll draw this one on. Press the M key. I'll grab the lung socket again. We'll draw this on. Draw this. Draw it again. Clear my masking. Turn off frame mode, and there you can see we can just keep adding these pieces and parts. Now, earlier I showed that some of these mesh insert brushes use curves. There's IMM curve, and this creates things like chains and stitches and buttons. So let's go to our tool menu, and we'll just select a polymesh star, so we've got a new object to work on. So if I were to grab something like, for example, this hose, if I click and drag, it draws a curve. Now I need to turn my draw size up and then touch the curve, and that'll change the size of what's being drawn along the curve. And you can see here, this is drawing a bit of hose along that curve. If I were to undo that and change to the stitch brush, you've already seen that this draws stitches along a curve. If I select this coil, I can draw a coil along a curve. Let's turn my draw size up and touch that curve, and we can increase the size of that so we can see it a bit better. Now, these are brushes that are intended to be used with a curve, so they will duplicate all along the length of that curve. If I undo this, we can grab chain with backplate, draw that. That creates two plates and a chain connecting them. So this is two different types of insert mesh brushes using curve. The first type is just the stitch. That has a single mesh that duplicates along a curve like this. If I were to take this star, go to the transpose gizmo and turn this into a cylinder, and we'll just increase the resolution of the cylinder. This has no subdivision levels. That's still important. We can't use any insert mesh brushes with subdivision levels. If I take the stitch brush and then draw it along the surface here, let me turn down my draw size, and let's go to our stitches. If I draw this along the surface like this, it draws stitches along the surface. If I take a curved brush like this and start drawing on the surface and then press and hold the Shift key, it will snap it into a ring that goes all the way around that surface. If I want to change the size of my insert meshes, change my draw size and then touch the curve, and that will change their sizing. And as I mouse over the curve, you'll notice that my brush turns blue. That means that I can manipulate the curve. so I can move the curve around while the brush is blue. If I change my draw size and click the curve again, that's going to change the size of the object. So be careful with that. If you change your draw size and then touch your curve again, it will change your mesh object size. If you want to get rid of the curve, just tap off the object, off the curve, and then that clears the curve. You can clear the mask. Once the curve is gone, you can't get it back. So it's not something that you can go back and edit. You need to place these things first, and then you can clear the curve and carry on. Now the other bits here, for example, the chain with backplate, this is called a tripart brush. This has 3 parts. It has the first mesh, which is the backplate. Let's turn the draw size up and click this. Grab the endpoint and move it. The first mesh is the backing plate. So if I go into frame mode, you can see there's 3 polygroups here. There's the first polygroup, which is the first mesh that's drawn. The second polygroup is the repeating mesh, which is the chain link. And then there's the last polygroup, which is drawn when you stop your stroke. That's the end cap. So that's a tripart brush. So let's look at how to create those now. I'm going to go back to a polymesh star. And actually, let's go back to our lung socket. Let's go back to our original lung socket. So instead of creating a single insert mesh brush like the lung socket that we did before, we're going to create one that draws along a curve. Now, the orientation of the object on screen when we store the insert mesh determines the orientation that it draws on the surface. If we want to use a curve, the orientation also determines the orientation along the curve. So imagine there's a curve that runs straight up and down through the screen, and the orientation of the mesh determines how it draws on that curve. So with the mesh stored like this, I'll go to Brush, Create Insert Mesh, and we'll just make a new one. Now, if I click and drag, it draws that on the canvas, but it draws in that orientation. What I want to do is go to the Stroke menu and tear this off. Under the Stroke menu, I have a menu for Curve. If I turn on Curve mode, now when I click and drag, it will draw this insert mesh along a curve like that. And that creates a very, very interesting effect. If I click on the endpoints of my curve, I can move them around and I can change their positioning. If I click on the curve itself, I can change the position of the curve. If I mouse over the curve while my cursor is blue, I can change my blue curve edit size and adjust that curve like so. Now I've also got the option to draw my curves as a line. So if I click and drag a new curve, that will draw as a straight line like this. I'll turn off as line. Snap forces the curve to snap to the surface. That's what we got with the stitches, where it was snapping to the surface underneath. Curve step will adjust the steps in our curve. If I turn that up and then click, you see it changes the steps in between each instance. If I turn that down and touch the curve, it'll update and it starts to become almost like a mechanical centipede here. Now we also can extend our curve. If I have not cleared the curve yet, if I mouse towards the end, I get this red line. Let's zoom in so you can see this. You see, if I mouse close to the end, let's see if we can't get it to continue. There you go. You see that little red line that connects the end of the curve? If I click and drag from there, I can then continue my curve. So that will carry on that line. So let's go ahead and turn off snap and let's bring our curve steps up a little bit again. We'll set this to 1, and then we'll touch the curve to update. There we go, that's a bit better. Now I can lock my start point, and that will lock the start point of my mesh. So if I were to move my curve around, the start point down here, the first point that I clicked on, will stay put, it won't move. I can lock the end point as well, and then the start and the end points are locked together so they won't move, and I can now adjust the mesh without changing the start and end points. Now if I turn these off, I can now manipulate the curve and the other end will follow suit. If I turn on elastic mode, zoom out a little bit, I can click on my curve and drag and it stretches the curve out. If I click on an endpoint, I can erase that curve. See how I'm just making that erase? I'm shortening it. If I turn on liquid mode, this liquefies the curve, so it allows me to basically stretch it out from the middle like so. Grab an endpoint, and I can erase just by clicking and dragging back down. It will shrink that curve. If I want to smooth my curve, maybe I've got a smaller draw size here. Let's turn off liquid mode, and let's change our draw size. Maybe I've got some inconsistencies in the curve that I don't like. I can smooth the curve based on my curve smoothness here, and then touch the curve again, and it will update the insert meshes. So the insert mesh along a curve is also great for hard surface. It can also be used with Dynamesh or organics, and I'll show you how we do that. If I go to, let's say, the polymesh star again, I'll turn this into a polysphere, and we're not going to add subdivision levels to this. We're just going to leave it as is for now, and I'll go to B for brush, C for curve. Now there's a whole variety of brushes that deal with curves here, and there's one called Curve Tube, and this draws a curve and then inserts a tube along that curve. And it's the same rules with the blue brush versus the red brush. I can bring my start point and I can countersink that into the mesh. If I have snap mode turned on, I'm not going to be able to get that point inside that mesh. So make sure that snap is turned off and I can pull that in. So let's draw one that's a bit shorter. We'll draw a curve like this. We'll countersink the first point in there, and we'll turn on X symmetry. Now when I touch the curve, I get a symmetrical effect there. Now watch this. If I go to curve modifiers and turn on size, and then open up my curve fall-off menu, this is the size of the tube at the start point. This is the size at the end. So this means it will go from small to big. If I flip this horizontally with the FH button and then touch my curve, it updates into a taper, which gives us this nice horn or tentacle. If I go to lock start, I can now grab the curve and I can adjust these horns or tentacles with the start point locked. Touch somewhere off the curve goes away, clear your mask, and now those meshes have been inserted just like the other insert meshes. If I Dynamesh this mesh, let's go to Geometry, come down here to Dynamesh, and we'll turn up our resolution in Dynamesh. And now I continue drawing these curves. I can countersink them, clear the mask. Now, because I've got Dynamesh mode on, once I clear the mask, I need to clear Control, click, and drag a second time. That executes Dynamesh and gets rid of the curve. So now this is all part of the geometry. And the faceting there is just because those facets were baked into the high resolution. We can get rid of that just with a bit of smoothing. So something I like to do with this brush is turn on radial symmetry. If I go to transform, turn off X symmetry, and turn on Z symmetry, and then turn on radial. Our radial count is 8. So now down the Z axis, I get symmetry here. Let's draw them on the bottom. That would be Y, the Y axis. So I'll go back to transform, and we'll turn off Z and turn on Y. So now I can get these tentacles growing out of the bottom. So we'll zoom out, turn our draw size down, click and drag. Now we get these cool tentacles, and I can use my blue brush to change their orientation. Tap somewhere off the curve goes away. Or you can just Control, click, and drag to clear the mask. Control, click, and drag again, and that Dynameshes those into the mesh. So I love using these for horns and tentacles and other sorts of protrusions. You can even use insert mesh brushes to draw out an entire character, which we'll see in just a moment. So these are insert mesh brushes using curves. Now, we're going to talk in a moment about the insert tripart mesh because we want to see how we can make our own, but I want to mention something else. If I have an insert mesh brush, say for example, my lung socket brush, and let's say for example, I want to get that mesh out of the brush, what I can do is go to Geometry, Modify Topology, Mesh from Brush, and that will extract that mesh from the brush. So now I can take this, we'll go to transpose. Let's turn off our radial symmetry. I'll unlock the pivot and center it. And if I control, click, and drag, I can duplicate this, and maybe I'll hold down the shift key and then rotate it a couple of axes here. Maybe we'll pull it up like this, clear the mask, and now I can make a new insert mesh, append it to the brush, and there we go. We can further edit an existing insert mesh brush just by extracting it from that brush. So if you've lost your original mesh, or if you've got a brush and the parts aren't quite right, you can always extract them and they will retain their polygrouping. So let's take a look at how to create a insert mesh brush with triparts. Then we'll talk about using insert mesh brushes with Dynamesh. So going back to what we learned about extracting meshes from brushes, I want to take a look at a zipper brush. So I'm going to go to B for brush, I for InsertMulti Mesh, and let's grab IMM zipper. Now IMM zipper has all these different types of zippers. We'll just grab the closed zipper. If I click and drag on the surface, it draws a curve, and you'll see that what it's doing is it's drawing the zipper pull, the teeth, and then the end cap. And once again, if you have any curve brush and you start drawing it on a surface, press and hold the shift key. It will snap it into a circle around the surface, and that's really useful for costumes. And also just, mechanical bits and pieces. It's just a nice behavior to know is part of that brush, so bear that in mind. That's drawing your curve, then press shift, and it will snap it to a ring. That's also useful for other curves in ZBrush, for example, the Z-Remesher curves. There's guide curves that we use for Z-Remesher, and this behavior also applies to those. So how does this brush work? Well, I'm going to go over here to the Polymesh star, and I'm going to extract it to show you. We'll go to Geometry, as we saw before, Modify Topology, Mesh from Brush, and that extracts the mesh from that brush. This brush only has this little mesh in there. So if we go into frame mode, you can see we have 3 polygroups. Now, the polygroups can be a little bit difficult to see. So if I click this and click this, there you go. You see this polygroup here is quite a similar color to that one, but it's definitely a separate polygroup. This is a tripart brush. This is the first polygroup. That's drawn when you first touch your brush to the surface. Then as you draw your curve, the second polygroup repeats along that curve. And then when you stop drawing, it caps it all off with the last polygroup. So we get this. There you go. Let's turn our draw size down. Draw it again so we get more teeth. As simple as that. So how can we make one of these on our own? Let's go back to the Polymesh star. Turn off frame mode. Oops, I just pressed Shift D. So I'm going to turn off my dynamic subdivision levels, go to dynamic subdivision levels, and just turn them off. I'm going to press the gizmo. Now, if you haven't watched the lecture yet on transpose and gizmo 3D and primitives, definitely do so, because there's an enormous number of primitives and modifiers available in here. And you can create all sorts of complicated objects using these. So what I'll do is I'll start by creating a polycube. Go into frame mode, and we can see our polys. This is a good resolution. I'll go to the transpose gizmo, and I'm just going to scale this down. We're going to create a belt that has an end cap on either side with a leather tab and metal ring. So this is going to be the length of our leather straps. I'm just going to expand this out a little bit here. And I'm going to hold down the control key, click and drag to duplicate this, and we're going to make a sort of leather tab that will attach the ring on the end. So I'm just going to scale this in Z, scale this down in Y, scale it in X, move it down. And I'm going to clear my masking. And I will come over here to my subtool menu, and I'm just going to duplicate my subtool, and I'll turn this into a Ring 3D. Scale this up. And this will be the ring along the end. Let's scale this up again. Let's make it about the same size as the belt. There we go. I'll Alt-click on the other subtool to select it, and I want to be able to manipulate this piece separate from this. They're part of the same subtool, so I will go to Polygroups, Autogroup, and that'll automatically polygroup the parts from one another. So I can now isolate that, mask it, invert the mask. We have a whole chapter just on working with polygroups if you want to learn more about that. I'm going to turn on my X symmetry, and I'm just going to use the Move brush here just to sort of pull these faces out, give it the impression of having a being deformed around this surface. There we go. And I can even use insert mesh brushes on something that I'm going to make an insert mesh brush from. So if I go to B for brush, I for insert, if we go to IMM model kit, let's grab a grommet of some sort or a rivet. This is a good rivet, a good fastener here. We'll click and drag to draw that. So now we have a fastener that's fastening that leather strip to the tab holding the ring. Now, what I want to do is I want to Control, Shift, click, mask this polygroup, reveal all again, and I'll just use my transpose gizmo, unlock it, reset it, lock it again, hold the Control key, click and drag to duplicate that, and then I can just rotate that. Make sure we turn off X symmetry. I can rotate that 180 degrees. Position this on the other side. And then I'm going to Alt-click on the subtool that I made for the ring, and I'll just do the same. I'll just go to the transpose gizmo, hold down Control, and I'll scooch this down so it's sitting at that end point. Now, I can't make an insert mesh brush from two polygroups, or excuse me, from two subtools that's a single brush. We can make an insert multi-mesh brush from subtools, and we'll see that in a little bit, but I need to merge these down so it's one subtool. So with this selected, I will go to Merge, Merge Down. Make sure I'm selecting the top group. There we go, Merge Down, click OK. So now I've got this set up as a single subtool. Now we need to create our polygroups. The first polygroup is the start group. That's the object that starts the curve. So I'm going to isolate those faces, and I'll go to Polygroups, Group Visible. Now I will invert my visibility, and I'm going to hide this polygroup, or these polys, and I'm going to polygroup this, Group Visible. Now I have three polygroups. This one's a little hard to discern because it's very similar to the other colors, so we'll just change that. So it's obviously three different polygroups now. Now I want to store this so we can use it as an insert mesh brush along a curve. Now remember, the curve runs straight up and down your screen here. Oops, I just drew another insert mesh. There we go. Straight up and down the screen there. So go to Brush, Create Insert Mesh, New. Now if I click and drag, it just draws an insert mesh. We need to turn on curve mode. So I will go to Stroke, under Curve, turn on curve mode, click and drag. Now it draws and then repeats that belt along the length, but you'll see that it's not fusing the parts. They're each separate. How do we fix that? We have to go to the brush menu. Under the brush menu, we will open up, let's close some of these submenus. We'll open up the samples menu. And here you see, oops, not samples, pardon me, under modifiers. Under modifiers, here you see we have our insert mesh. We have tri-parts turned on. Now that's turned on by default when you store this mesh and it has three polygroups. This tells the brush that it's a tri-part brush, that it wants you to use the polygroups along the length. To weld the points, we turn on weld points. Now if I click the curve, those points weld together. And there we have a bit of belting with connecting points on either end. Now, if I go back to my stroke menu, tear this off, Remember that we have our other tools here. Let's close out of curve modifiers and go to our curve functions here. Remember that we have elastic mode and liquid mode. So if I change my draw size and then click and drag while holding the control key, I can twist what's happening along this curve. Now we need to make sure that you are starting your stroke, click and then hold control, and that allows you to twist what's happening along that curve. If we go into frame mode, it retains our poly grouping. Turn off frame mode, tap somewhere off the curve goes away, and now we have our actual mesh. So that's how we create an insert mesh brush along a curve that uses triparts. If I want to save this brush, just go to the brush menu and click Save As, and it will save as that particular brush. Now what I will do is I will undo these strokes, and I will save this particular piece so you'll have access to it, and you can download this and you can see for yourself how this was created. So I'm just going to save this as, and my save window is off screen right now. We'll just call this belt, curve tool. And I will save the brush. So I'll go to brush, save as, and we'll call this belt IMM curve. So both of those will be available to you in the downloads. And if I save this brush with these settings enabled, the weld points, that will save with the brush. So it will always work the same way. So one more thing I want to talk about with regards to creating your insert multi-mesh brushes is if you have Z-tools sitting around that have multiple subtools. Say, for example, the skeleton mesh here. The skeleton mesh is composed of multiple subtools of different bones. Now, this is a neat trick. If I go to Brush, instead of clicking Create Insert Mesh, if I click Create Insert Multi Mesh, this will create a brush out of all those different subtools. So now I've got a brush that will insert skeleton parts. So I can insert rib cages, or I can insert skulls, and it will store the meshes at whatever subdivision level is active in that subtool when you create the brush. So this would be great for populating a dungeon floor, maybe. We can put some kneecaps on here, or we can put some sets of teeth. You could also just use this to construct a new character. And that brings us to using insert mesh brushes with Dynamesh. So this is different from what we've done mostly so far, which is inserting mechanical pieces and parts. Now let's look at how we can use insert mesh brushes to add volumes and organic forms. So I want to initialize my ZBrush. I'm going to go to Preferences, Initialize ZBrush, and say yes, and that just clears out everything that I've loaded in and gives us a fresh new ZBrush. I'll select a polymesh star, draw it on the canvas, go into edit mode, and then using the transform gizmo, I'll turn this into a polysphere. Let's go ahead and add a couple subdivision levels to it to smooth it off. And then I will go to Geometry, Dynamesh. Let's turn up our resolution and then Dynamesh this. We don't want to freeze our subdivision levels. So now we've got a Dynamesh mesh with no subdivisions. So let's go to B for brush, I for insert, and select IMMB parts. This is a brush that's specifically intended for using with Dynamesh because it inserts organic pieces. So for example, if I wanted to create 2 ears on this sphere, and turn on X symmetry, go to the sides of this mesh, draw 2 ears. Now you see they draw separately. They draw just like the other insert mesh brushes do. I might take the transpose gizmo and countersink them into the model a little bit, change their orientation. Perhaps I'll control click on the background to invert the masking, so then I can take the move brush and just sort of adjust the shape of the underlying mesh so it intersects a little bit better with the ears. And then I will take the parts that are crashing through the ear here and just push them in. Control, click, and drag once clears our mask. Now, because we have Dynamesh on, if I control, click, and drag a second time, it glues those parts together. So I can start building up a character out of pieces and parts. So let's take our move brush and let's just pull this down into a little chin here, a little bit of a face. Pull this forward. I'll go to B for brush, I for insert, select IMM parts again, and this time I'll grab a mouth. Bring the two dots together so I'm on the center line, and we'll drag a mouth out. We'll take the transposed gizmo and just push that back along the surface. Maybe rotate that a little bit. And then invert the masking. And I can use my move brush to push any crashing faces in a little bit so we get a better transition into the mouth like this. And then clear the mask, execute Dynamesh. And the resolution of the resulting mesh is only going to be as good as the resolution of your Dynamesh. I can take my clay tubes brush and turn the alpha off, turn my focal shift down, and I'll just do a little bit of cleanup on the edges here. Execute Dynamesh. There we go. I'll turn down the Z intensity on my smooth brush, and that makes the smooth brush a little less destructive. We'll take the dam standard brush, and with the dam standard brush, we'll just correct the little corners of the mouth there. And then do a little bit more smoothing here. Take the clay tubes brush. Get the nodes in the mouth there. Let's turn up the intensity on our smooth brush again so it's a little bit stronger. Great. Let's put a nose on there. So we go back to B for brush, I for insert, IMM parts, and then grab a nose. Bring the two dots together so we're at the center. We can draw a nose. Let's make the nose really big. This will be a very strange looking character as it is. Transpose, we can position the nose where we want it. We can rotate it. Take the move brush, adjust any sort of intersections that we want to adjust, and then control, click, and drag twice to glue the parts together. Now I'm going to go to B for brush, I for insert, and I'm going to select IMM primitives, and this just inserts primitive shapes, and these can be used for hard surface or Dynamesh. If I select insert sphere, start to draw, but I hold down the Alt key. This will create a subtraction object. Now it's a little tricky to see it. If I move it out of the mesh, you can see the normals are flipped. It's inside out, and that's just a visual cue to let us know that that is a subtraction mesh. So now if I control, click, and drag twice, it will subtract that object instead of adding it. If I take the same sphere and draw it without pressing the Alt key, you see it draws like we normally expect it to. Now if I execute Dynamesh, it glues those spheres in. Now if you watch the lecture on polygrouping, you'll know that there's another way that we can create a subtraction object like this. If I click and drag, without holding down the Alt key, position that sphere, okay? Then go into frame mode. You see everything that I've inserted has its own polygroup. If I Control-Shift-Click on those spheres, go to my polygroup menu under the tool palette. So go to polygroups. We have the option to click Group as Dynamesh Sub. Click that, and it puts a white polygroup on those meshes. So now, if I clear the mask and execute Dynamesh, it does the same subtraction. And that can be a little bit easier to see. It also allows you to duplicate objects using the polygroup control, click, drag, and then make a subtraction out of all of them. So it can be a little bit easier to subtract like that. I quite like using the insert sphere brush just to build up characters in general. I treat these like balls of clay. So I'll position them, take my move brush, change the shapes, make sure our X symmetry is turned on so we can put our cranial mass in the back of the head here. Bring that down. Do a little bit of smoothing. Let's turn up the Z intensity on our smooth brush so it's a little bit more aggressive. Look at it from the top. I'll turn off perspective so we don't have so much distortion here. A little bit of smoothing. Bring it down here, and then glue those parts together. And then I can just take the smooth brush and smooth them back. Now, let's say I wanted to add a body. B for brush, I for insert, go to IMM body parts, and just grab a torso. I bring the two dots together, click and drag, and that draws a single torso, masks the head, I can then move this around and position it where I want it. If I click the go to unmasked mesh center, it will center the pivot on the unmasked portion of the mesh. And there we go. And then control click and drag twice, and it dynameshes. Now it's going to bake in the faceting, so I can just smooth that away with my smooth brush. But you'll notice that it's two separate objects because nothing was intersecting. So now I'll just go to B for brush, I for insert, go to our primitives, insert a sphere here, use transpose to move it into place, and we'll just turn this into a neck. I'll just take my move brush and we can scooch these shapes around and create a connecting neck here. Execute Dynamesh, go into frame mode, and you can see that these are connected meshes now. So you can very easily start to build up new shapes. If I want to get rid of anything, I can simply hide it. So if I go to my B for brush, S for select, L for lasso select, click OK, I can hide parts of this mesh using the lasso select brush like that. Go to geometry, modify topology, delete hidden, execute Dynamesh, and then it'll just plug that hole. Now, if I don't like the way it's scalloped out like that, what I can do is just add another sphere in there. So I'll go to B for brush, I for insert, go to our primitives. We'll just draw a sphere inside of here. We'll position it and scale it. And then we can just use the move brush to shape it where we want it. Bring it out here so we can fill out that negative space. Oops, I didn't mean to clear my mask there. I'll take my trim dynamic brush and just sort of plane back these shapes a little bit. Use move to pull these out. There we go. Bring this forward. And then execute Dynamesh, and then I'll glue all those parts together. And then I can use my B for brush, T for trim. Trim dynamic is kind of my favorite brush for creating planes and sort of refining surface forms. I'll just knock back a plane here and a little base here, and we're starting to create a little bust. We can move up here and smooth out any of these areas, and then plane this back. So here you can see how very easy it is just to start building up shapes using primitives like this and using insert mesh brushes like IMM B parts. If I were to grab the arms here, we can draw two arms, use transpose to move them around and position them into place. I can hold down the Alt key and change my pivot position. That makes it a bit easier to manipulate these arms. We'll get them placed where we want them, and then I'll just execute Dynamesh, and it will, we'll glue those together. Now you see that it missed that little gap right there. So if I undo, back to my masking, invert the mask, and I'll just take the inflate brush, and I'll inflate all the faces underneath there so it meets the arm. Then execute Dynamesh, it glues those together more effectively. Then I can take my move brush, bring the armpit up, clear this off. We can go back to our insert primitives, grab a sphere. We can draw a sphere here and make a scapula. So I'll just take the move brush and shape this into the shape of a shoulder blade. We'll use the transpose gizmo to squash it down and then rotate it and position it. And we'll let this also be the back of the armpit. We'll sort of cheat it so it's also the muscle shapes that we get back there. It's not a super realistic figure. It's a little bit cartoony, but that's no problem. Mask that out. And then if I want to create a bridge across here, I just do the same. B for brush, I for insert. Insert another sphere. We'll just scale that down, position it. And then take our move brush and place it how we want it to orient on the surface. I'll take the inflate brush and just inflate this a little bit so it's sort of intersecting there, and then clear our mask and execute Dynamesh. Now I'll turn up the Z intensity on my smooth brush, and that allows us to continue building up a shape here. So the insert mesh brushes don't have to only be for hard surface. You can absolutely use them for organics, and in our Dynamesh chapter we actually do that as well. So we use these elsewhere in this video series. So I just wanted to dedicate some time to just explicitly talk only about Dynamesh and Dynamesh with organics, as well as Dynamesh with hard surface. So hopefully now you've got a good idea of how the insert mesh brushes work, how you can create your own insert mesh brush, your own InsertMulti Mesh brush, and your own insert mesh brush along a curve. So as I promised, I wanted to illustrate how I went about simplifying a more complicated object, the lung socket here. So here we have the lung socket. It has 3 subtools. The first subtool, if we turn on solo mode, are the claws. Now, we talk about how these were created in the video on text 3D and vector shapes, so be sure to watch that if you're curious. These are already just a single subdivision level. There's no geo beyond the first subdivision level, and they're pretty low resolution as it is, so we'll keep those as they are. The next is this ring of those blades, and that is sitting on the inside of the socket, and that's created using Array Mesh. Array Mesh is under Tool. Let's close Geometry and go to Array Mesh here. This is instancing. So there's a whole chapter just about Array Mesh. If I turn this off, you see we go back to just this version. It's just a duplicate of the other legs. If I turn on Array Mesh, you can see that it's set to rotate 360 degrees around the y-axis, and it repeats 6 times. So if I turn that up, I get more. Turn that down, I get fewer. So we'll set it back to 6. And there is our array. But that's not actual geometry, so I can't make this into an insert mesh brush. So what I need to do is click the Make Mesh button, pardon me. Make Mesh, and that turns this into actual geometry. If I turn off my frame mode, and let's increase our repeats here. There we go, Make Mesh, and now we have actual geo. If I go into frame mode, Shift F, that's all actual geometry, as you can see. Now, if I want these to actually join together, a neat trick, and this is covered in more depth in the chapter on transpose deformers, is we go to Remesh by Union, and this will now remesh these together. It's a little hard to see unless we zoom in. These are no longer just intersecting meshes. These are now grouped or joined together topologically by union. Of course, we could also go to our remesh options under the deformers, and we could remesh by Z-Remesher or remesh by Dynamesh, but because this is an insert mesh brush, we want this to be as simple, as low resolution as possible, because we may potentially insert hundreds of them. Which brings us to the last part, the socket itself. Now, this is very dense. If we mouse over this, you can see this is actually over 1 million polygons. So what we need to do here is use Decimation Master under the Z plugin menu. Decimation Master, we have a whole video just on Decimation Master, but in a nutshell, it decimates or simplifies a mesh by triangulating it. So it's no longer quad faces, it's all triangles. It clusters more triangles in areas of high detail and fewer triangles in areas of less detail. The point is that it retains the look of detail while reducing the overall poly count. So what we need to do is click Preprocess Current, and that will process this mesh. It writes out a cache file. And once that cache file is complete, we'll use this slider here, K polys, to set the thousands of polys that we want for our target. Now this is covered in more depth, like I said, in the Decimation Master and 3D printing video as part of this series. But for an insert mesh brush, it's fine for us to decimate it like this. It's fine for us to triangulate it because we don't really need to worry about it having workable topology just yet. Once we have it all put together, we can worry about changing the topology later. The idea is for our insert mesh brushes to be as lightweight as possible and maintain their detail. So it's finished writing the cache file. If I come over here and go to thousands of polys, we'll turn on frame mode with Shift F so you can actually see the mesh. So you can see it's quite dense. If I change this to 20,000 faces and decimate current, it will triangulate it like so. Smaller triangles in areas of more detail, bigger triangles in areas of less detail. Turn off frame mode and you can see it looks pretty good. It actually would probably work quite well at the scale I would intend to use this, but we still have faceting. So we'll undo that and we'll change this to 40. Now with 40 set, I'll click decimate current, and now it triangulates again, but it gives us a bit more detail. It's still pretty low resolution compared to what it was. Now I'll turn off solo mode and we'll go up to the top, and I will go to the merge menu here, and I can click merge visible, and that creates a new subtool where all of these parts are merged together like so. You can see that that's a single subtool. I can now go to brush, create insert mesh, new, and now I have a new insert mesh built from that part. So that's how we take something that is a complicated multi-subtool object with subdivision levels and prep that and make it possible to turn it into an insert mesh brush. So I hope you've enjoyed this video and you've learned much about insert mesh brushes and curve brushes that you can use in your own art and your own creations in ZBrush. So thanks for watching, and I'll see you in the next lesson.